Well, let's find out. Also, okay.
Where's Bella?
Yes.
Put this on your desk.
Okay, that's fine. All right. Polynomials in factored form. Part 2. That's not right. Because we did this once before. All right. Given, for example, this will be very similar to something we did before. If you remember it, this won't take long. We're going to mix and match what we did a couple weeks ago with what we did on Friday. Okay? I'll post these notes later, but if you take them right now as well, you'll be ready in case it takes me a while to post them. Okay, given. We're going to make up a polynomial. We're going to graph it. We're going to ignore that. Given f of x equals.
Did you like practice this all weekend?
You will wish that I had. Actually, no, I did not. But I practiced it a little bit Friday. All right. Okay, given this polynomial here. That's a little hard to make bigger right now. Sorry, Amy. Can you read it okay?
No, I'm not a count.
Okay. X plus 1 squared, x minus 1, x minus 3. All right. What would you expect the y-intercept to be? How would you find the y-intercept? How do you find the y-intercept?
To be -3. No, wait. No. Right.
Okay, look at this. What would you expect the y-intercept to be? You're on the right track.
+3.
Why do you think it would be either, what are you doing to try and get +3 or -3? James Saul?
So you to make the positive anything. Or no, you have to make that the constant, right?
That would be at the end if you multiplied it out. Yeah. Let's see what will happen. The y-intercept by definition is f of 0, right? So you put 0 in for every x. So you've got 0
So it is -3.
plus 1
No,
squared.
-2.
0, can't type it right, minus 1 times 0 minus 3. What does this actually work out to?
+3.
Positive 3. Because with the zeros, it's just going to be 1 times -1 times -3. So that's going to equal +3 when we're done, right?
Yeah.
Okay. Here we go. How's that compare to my handwriting? A little better?
It's actually legible.
It is actually legible. Isn't that amazing? Okay, so that's the y-intercept is at 3. All right, next one.
Why does it have stars, towers of 1 and
That means multiplication.
Oh.
Are you doing this on the net?
Yeah.
Yay.
Okay, that means multiplication. That's another way. It's the way to write multiplication in some computer programs. I should have explained that. That's right. Or I should have used x's maybe.
All right.
Okay, what is the degree of the polynomial? In other words, when you multiply all those x's together, what power is it going to be raised to? You've got an x plus 1 squared, an x minus 1, and an x minus 3. So when you're done multiplying the x's, what will you get? X to the fourth. This will be a 4th degree polynomial.
Is that because the square makes the other x have 2?
Exactly. Because it's going to be x squared times x times x. Led by x to the 4th. Superscript is a pain in word. All right, 4th degree. Now, what is the leading coefficient? What's going to be in front of the x to the 4th, in other words? Now, that's at the end. That's a constant term. That's a number at the end.
Number?
If you were to multiply all this out, what coefficient would be in front of x to the 4th? You figured out you're going to get x squared times x times x. What's going to be the leading coefficient? Is a simpler question than it sounds?
That
One.
answer.
1. I said simpler question, and it's all got it. It's going to be 1. So here's what we know. We know that f of x, if we were to multiply it out, would equal x to the 4th plus dot, 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 plus 3 at the end. There'd be some stuff in the middle, but we know it would look, the function would look something like, final form of the function would be like that. And we don't have to multiply it out any further to graph it. Okay, we've talked about this a couple different times. So it's going to be 1x to the 4th. 1 is positive, right? That's not supposed to stump you guys. 1 is positive, right?
Yeah.
Yes, thank you. Okay. 1 is positive, and 4th degree, is 4 even or odd?
Even.
Nice, Layla, thank you. And 4th degree is even. So, we have end behavior in the form of a touchdown, ballerina, marionette. Other one, touchdown, positive, 1 is positive, 4 is even, in the form of a touchdown. If I could type, I could rule the world.
That's not necessarily the way it works, but you can think that.
I'm going to think that. I'm just going to keep dreaming.
Okay.
All right. So now, the graph itself. And the graph I'm going to put on the next page because